Hello friends, imagine a serene night far away from the bustling lights of the city. You gaze upwards and see countless stars dotting the vast expanse of the sky. These stars are part of the Milky Way galaxy, our cosmic neighborhood. The Milky Way is a colossal, spiral-shaped galaxy brimming with stars, planets, gas, and dust. This galaxy is our home, the location of our solar system. However, beyond the reaches of the Milky Way lies another majestic spiral galaxy known as Andromeda. Andromeda is even more immense than the Milky Way and holds the title of the closest spiral galaxy to us. The Milky Way and Andromeda are not just static collections of stars, they are dynamic systems constantly influenced by the gravitational forces within and around them. One of the most fascinating and inevitable events in the universe is the impending collision and eventual merger of these two galaxies. This grand cosmic event, expected to unfold in about 4 billion years, offers us a glimpse into the workings of the universe. First, let's delve into the structure of the Milky Way and Andromeda. The Milky Way is classified as a barred spiral galaxy. This means it features a central bar-shaped region composed of stars with spiral arms winding outward from this bar. These spiral arms are rich with young, bright stars and vast clouds of gas and dust where new stars are continuously being born. Our solar system resides in one of these spiral arms known as the Orion Arm. The central region of the Milky Way is densely packed with stars and contains a supermassive black hole named Sagittarius A*. In contrast, Andromeda, also known as M31, is a giant spiral galaxy similar in shape to the Milky Way but significantly larger. It boasts a bright central bulge surrounded by extensive spiral arms that stretch far into space. Andromeda's mass is approximately 1.5 times that of the Milky Way, and it too harbors a supermassive black hole at its core. Both galaxies are home to billions of stars, numerous planetary systems, star clusters, and nebulae. The collision between the Milky Way and Andromeda is driven by their mutual gravitational attraction. Although they are currently separated by about 2.5 million light-years, this distance is gradually decreasing at a rate of approximately 110 kilometers per second. Over billions of years, this steady approach will bring them closer together, setting the stage for an inevitable collision. When we think of a collision, we often imagine a violent crash. However, the collision between the Milky Way and Andromeda will be more akin to a slow, intricate dance. Galaxies are predominantly empty space with vast distances separating individual stars. Consequently, the likelihood of direct star-on-star collisions is extremely low. Instead, the gravitational forces of the two galaxies will interact, pulling and stretching their structures in a graceful ballet. As Andromeda draws nearer to the Milky Way, the gravitational interactions will begin to distort their shapes. Tidal forces will stretch the spiral arms, creating long streams of stars and gas that extend far into space. These tidal tails are a common feature in galactic collisions and provide a visual testament to the gravitational forces at work. The initial approach will likely trigger bursts of star formation, as the gas and dust in both galaxies collide and compress, leading to the birth of new stars. Over the next few billion years, the Milky Way and Andromeda will continue to interact, their shapes becoming increasingly distorted. They will pass through each other several times, their mutual gravity causing stars to be flung into new orbits. Some stars may be ejected into intergalactic space, while others will settle into new positions within the merging galaxies. During this process, the supermassive black holes at the centers of both galaxies will also move closer together. As the galaxies merge, their central black holes will eventually coalesce. This event will release a tremendous amount of energy, potentially creating powerful gravitational waves. These ripples in the fabric of space-time could be detected by future gravitational wave observatories, providing direct evidence of the black hole merger. The combined black hole will reside at the center of the new galaxy, exerting a strong gravitational pull on the surrounding stars. The final result of this cosmic dance will be a single, larger galaxy. Astronomers predict that the merged galaxy will likely be an elliptical galaxy, a common outcome of spiral galaxy mergers. Unlike spiral galaxies, which have well-defined arms and a flattened disk shape, elliptical galaxies are more rounded and lack distinct spiral structures. This new galaxy has been given the name Milkomeda, a blend of Milky Way and Andromeda. The Milky Way-Andromeda collision will have significant effects on the structure of both galaxies. The combined gravitational forces will create a new distribution of stars, gas, and dust. Star formation will continue in regions where gas is dense enough to collapse under gravity. Over time, the intense bursts of star formation will subside, and the new galaxy will settle into a more stable configuration. Our solar system, located in the Milky Way, will also be affected by this galactic collision. However, current simulations suggest that the solar system is unlikely to be ejected from the new galaxy. Instead, it will likely find a new orbit within Milkomeda. Life on Earth, if it still exists billions of years from now, will witness a dramatically different night sky. The sky will be filled with new stars, and the view of the galaxy will be unlike anything we see today. One of the most intriguing aspects of studying the Milky Way-Andromeda collision is that it provides insight into the dynamic and evolving nature of galaxies. Galactic collisions and mergers are not rare events. They have been happening throughout the history of the universe and will continue to occur. These interactions play a crucial role in the formation and evolution of galaxies. By observing other galactic collisions in the universe, astronomers can learn more about the processes that will shape the future of the Milky Way and Andromeda. For example, the antennae galaxies are a pair of interacting spiral galaxies that provide a glimpse into the early stages of a galactic merger. These galaxies are currently undergoing intense bursts of star formation, similar to what will happen when the Milky Way and Andromeda collide. Studying the Milky Way-Andromeda collision also helps scientists understand the role of dark matter in galaxy interactions. Dark matter is a mysterious substance that makes up a significant portion of the universe's mass but does not emit or absorb light. It exerts a gravitational pull on visible matter, influencing the motion and structure of galaxies. By modeling the collision and merger of the Milky Way and Andromeda, astronomers can gain insights into the distribution and properties of dark matter. In addition to dark matter, the study of galactic collisions can shed light on the behavior of supermassive black holes. The merger of the Milky Way and Andromeda's central black holes will provide a unique opportunity to observe the dynamics of these enigmatic objects. Understanding how black holes interact and merge can help answer fundamental questions about their formation and growth. The Milky Way-Andromeda collision is a testament to the ever-changing nature of the universe. It reminds us that galaxies are not isolated islands, but are constantly interacting and evolving. These interactions shape the cosmos, leading to the formation of new stars, planets, and galaxies. The eventual merging of the Milky Way and Andromeda is a natural part of this ongoing process. For astronomers and space enthusiasts, the Milky Way-Andromeda collision offers a fascinating glimpse into the future of our galaxy. It highlights the power of gravitational forces and the dynamic nature of the universe. By studying this event, scientists can better understand the processes that govern the evolution of galaxies and the broader cosmos. This galactic collision is a cosmic spectacle that offers a window into the life cycles of galaxies. The slow, intricate dance of the Milky Way and Andromeda, culminating in their eventual merger, illustrates the grandeur and complexity of the universe. The forces at play, primarily gravity, demonstrate how galaxies interact and evolve over billions of years. This process, though gradual, has profound implications for our understanding of the cosmos. When considering the future collision of the Milky Way and Andromeda, it's essential to appreciate the scale and time scale of such an event. While 4 billion years might seem like an unfathomably long time, it's relatively short in the cosmic timeline. Our universe is about 13.8 billion years old, so this upcoming merger is just another chapter in its ongoing story. The journey of these two galaxies towards each other is a slow and majestic process. As they draw closer, the gravitational forces between them will become increasingly significant. These forces will stretch and distort the spiral arms, creating spectacular streams of stars and gas. These tidal tails, a hallmark of galactic interactions, will paint a dramatic picture in the night sky, visible even from Earth. The initial phases of the collision will be marked by bursts of star formation. As the gas clouds in both galaxies collide and compress, they will trigger the birth of new stars. These star-forming regions will shine brightly, contributing to the overall luminosity of the merging galaxies. The night sky, viewed from Earth, will be filled with new, brilliant stars and glowing nebulae. Throughout the collision, the structure of both galaxies will undergo significant changes. The spiral arms will lose their distinct shapes, and the galaxies will take on more irregular forms. Stars will be flung into new orbits, some traveling great distances from their original locations. The gravitational tug-of-war will continue for billions of years, with the galaxies passing through each other multiple times. During these interactions, the central black holes of the Milky Way and Andromeda will gradually move closer together. These supermassive black holes, each millions of times more massive than the Sun, will eventually merge in a cataclysmic event. The energy released during this merger will be immense, potentially creating gravitational waves that could ripple through the fabric of space-time. Gravitational wave observatories, such as the Laser Interferometer Gravitational Wave Observatory, LIGO, could detect these waves, providing direct evidence of the black hole merger. This would be a groundbreaking observation, offering insights into the dynamics of supermassive black holes and the extreme conditions of their environments. As the galaxies continue to merge, the process of star formation will eventually slow down. The intense bursts of new stars will subside, and the merged galaxy will settle into a more stable configuration. The resulting galaxy, Milky, will likely have an elliptical shape. Elliptical galaxies are common outcomes of spiral galaxy mergers, characterized by their rounded shapes and lack of distinct spiral arms. Milky will be a massive elliptical galaxy, a new home for the stars, planets, and other celestial objects from both the Milky Way and Andromeda. Our solar system, while affected by the gravitational interactions, is expected to remain within the new galaxy. The night sky, as seen from Earth, however, will be forever changed. New constellations will form, and the view of the galaxy will be entirely different from what we see today. Understanding the Milky Way-Andromeda collision also helps scientists explore the broader context of galactic evolution. Galactic collisions and mergers are not isolated events. They are part of the cosmic cycle that shapes the universe. By studying these interactions, astronomers can gain insights into the processes that govern galaxy formation and evolution. Observations of other interacting galaxies, such as the antennae galaxies, provide valuable analogues for the Milky Way-Andromeda collision. These galaxies, currently in the early stages of merging, exhibit intense star formation and dramatic tidal tails. By studying such systems, scientists can better understand the stages and outcomes of galactic mergers. Dark matter, a mysterious and invisible substance, plays a crucial role in these interactions. Dark matter exerts a gravitational pull on visible matter, influencing the motion and structure of galaxies. By modeling the Milky Way-Andromeda collision, astronomers can learn more about the distribution and properties of dark matter. This knowledge is essential for understanding the overall mass and dynamics of galaxies. The behavior of supermassive black holes during galactic mergers is another area of keen interest. These enigmatic objects, located at the centers of most galaxies, have a significant impact on their surroundings. The merger of the Milky Way and Andromeda's central black holes will provide a unique opportunity to observe the dynamics of these powerful entities. Understanding how black holes interact and merge can help answer fundamental questions about their formation, growth, and influence on their host galaxies. The Milky Way-Andromeda collision is a reminder of the dynamic and ever-changing nature of the universe. It highlights the intricate dance of gravitational forces that shape the cosmos. This cosmic event is not a cause for alarm, but an opportunity to deepen our understanding of the universe's evolution. For astronomers and space enthusiasts, the Milky Way-Andromeda collision offers a fascinating glimpse into the future of our galaxy. It underscores the power of gravitational interactions and the transformative effects of galactic mergers. By studying this event, scientists can gain valuable insights into the processes that govern the formation and evolution of galaxies. In conclusion, the collision and merger of the Milky Way and Andromeda galaxies are inevitable and awe-inspiring events in the universe. Over billions of years, these two spiral galaxies will come together, their shapes distorted by gravitational forces. The collision will trigger bursts of star formation, create tidal tails, and eventually lead to the merging of their central black holes. The final result will be a new, larger galaxy, likely an elliptical one named Milkomeda. This cosmic dance provides valuable insights into the nature of galaxies, dark matter, and supermassive black holes, reminding us of the ever-changing and dynamic universe we inhabit. Please like, comment, and share the video, and please do not forget to subscribe for more videos.